right, so let's review how we factor so far. When we have 4 terms, chances are we're probably going to be factored by grouping. And just to double check, I noticed that the GCF for this is 1. So since there are 4 terms, I can split them down the middle. The GCF for these 2 terms is 2x. And when I factor that out, I get a 2x plus 1. The GCF for these 2 terms is 1. And when I factor that out, it gets absolutely the same. The reason I know I did this correctly is because these 2 are the same. That is our GCF for the entire polynomial. And then the leftover, the 2x and the plus 1, are the other factor. So in fact, you could even write it like this if you want. Same thing is true for this. The GCF for all 4 terms is 1. So our next strategy is we're going to try grouping. The GCF here is x. We get x plus 9 when we factor that out. And here they both have a 2, and since they're both negative signs, it's going to be negative 2. Again, I know I did this correctly because these are a match, so that's one factor. And then the other factor is x minus 2. So let's move on to something that has 3 terms, 1, 2, 3. What happens when we have 3 terms if our GCF is 1? Well, what we're going to try to do is we're going to try to make it into 4 terms. So somehow we're going to try to make this polynomial look something like this, where it's got 4 terms instead of 3 terms. So before we do that, we have to identify standard form. The standard form is when our variables are listed in greatest exponent to smallest exponent. So here we have our 2. Technically we have an exponent of 1, and here we don't even have an exponent because this is a constant. So it goes from biggest degree to smallest degree. So notice the a is always in front of the square term. And c is always the constant. The b is always the one that's next to the variable that you don't see an exponent, so the degree is going to be 1. So let's double check. Here we have 3x squared plus 5x plus 4. The a is always next to the degree of 2. The b is always next to the variable with no exponent listed. And c is always going to be our constant. Here is our x squared term. There's no number here, but we do know that this represents 1, x squared, so a is 1. B is careful, it's negative 5, and c is 3. Here I'm going to rearrange with my commutative property so that they're in order from largest degree to smallest. So now it's in the right order, standard form. I can see here that a is 2, this is going to be negative 1, and c is 7. And then finally notice there's no x, there's nothing in the middle. So since there's nothing in the middle, I can rewrite it as 0x. And now I can see a little bit more clearly that 16 is a, 0 is b, and c is negative 9. All right, so let's start factoring. Here we have 3 terms, and there's GCF as 1, so our goal is to make this into 4 terms. So we're going to use our little number puzzle. I'm just going to list that a is 4, b is 4, and c is 1. All right, so we're looking for 2 numbers. We're looking for 2 numbers that multiply to make whatever a times c is. So let's start there. What is a times c? 4 times 1 is 4. And what's b? It's also 4. I'm looking for 2 numbers that have to be the same. So what 2 numbers can we multiply to make 4 but also add to make 4? And the answer is 2 and 2. So what does that mean? That means that this middle term right here can be rewritten as 2x plus 2x. So what I've done is instead of 4x, I've broken it apart into 2 different pieces, 2x and 2x. And the way I got the 2 is right here. Those are the 2 numbers that made these true. And now that I have my 4 terms, I can take out the GCF. I get 2x plus 1 is one GCF, 2x plus 1 is the other factor, or if you want to be fancy, 2x plus 1 squared. Okay, so the next one I'm going to actually rewrite into standard form because it's a little bit out of order. Got a is 1, b is negative 1, and c is negative 12. So first thing I want to do is a times c. So 1 times negative 12 is negative 12. b is negative 1. All right, so I need to think of two numbers that multiply to make negative 12. So what could that be? Negative 4 and 3. 4 and negative 3 could be 2 and negative 6, negative 6 and 2, 1 and negative 12, negative 1 and 12. And which one of these can also make a negative 1? So it looks like this. So negative 4 times 3 makes negative 12, and negative 4 plus 3 makes negative 1. So x squared stays the same. We're going to break apart the middle into negative 4x and positive 3x. Because if I combine them, I'm going to get exactly what we started with. And then I'm going to use my factor by grouping. I know I did this right because these are the same, so that's one factor that they have in common is x minus 4, and the other factor is x plus 3. If I multiply these out together again, because factor means multiply, these factors, when multiplied together, will make x squared minus 12 minus x. All right, and our final example. This only has two terms. The GCF is 1, but I can rewrite it like this. So a is 4, b is 0, and c is negative 9. So I'm looking for a times c, so 4 times negative 9 is negative 36, b is 0. So what can I multiply to make negative 36, but those same exact numbers also add up to make 0? I think it's negative 6 and 6. So instead of 0x, I'm going to break it up into negative 6x and positive 6x. GCF is 2x on this side. Looks like the GCF is 3 on this side. Oh, I know I did this properly because it looks like these match up. So 2x minus 3 is one of my factors. Oh, and it looks like 2x plus 3 is my other factor.